All right, so let's talk about AI. It's really the point here. It's affecting everyone, and it's also affecting OT. And there's a distinction made here between these various types. The basic point is AI is the overarching field of computers that learn to do something without being explicitly programmed to do that thing. So if they play chess, there's old-fashioned technique where a human has just written a bunch of branch statements to evaluate the board and planned the strategy and programmed it. But an AI would learn to play chess by playing chess and just learning what works and what doesn't. So it ends up doing something without a human controlling how it does it, and therefore it's not terribly easy to explain why it does it or to change how it does it. That's for the general field of AI. And then there's machine learning and large language models. Machine learning typically applies to activities that are not related to human language. I think you probably could say that LLMs are a subset of machine learning, although I'm not sure if that's exactly true. But anyway, LLMs are the ones that specifically work on large bodies of text or spoken word, understanding or simulating an understanding of written or spoken language. That's the point of large language models, and it turns out to be so powerful and so useful that it's a special field of itself, as opposed to the rest of machine learning that does things like find exceptions so they can remove defective products from lines, fit lines to curves so they can extrapolate trends, and so on. There's an intermediate step, meaning deep learning. Well, machine learning, deep learning, LLMs, you could say that. Okay. Deep learning is just a multi-stage technique of applying these. I think you can in principle use deep learning for machine learning or for LLMs, but yeah, there's also a special encoding required for LLMs. LLMs are like a specialization of machine learning. Yeah, that's a fair statement, I guess. All right, so AI, in principle, you might be able to predict equipment failures and optimize your processes and detect deviations. This is the kind of thing we're all hoping to do in security all around, to somehow detect the anomalies better and identify defects and inconsistencies. And so maybe you could improve your supply chain by planning, optimizing your inventory levels, and so on. This is something, when I first saw those Safeway loyalty cards come out maybe 3 decades ago, I was running databases at the time, and I said, wow, if I had this data, I could do things. The only thing I thought of, though, being not very imaginative, is I could at least make sure that all the food sells before it goes bad. I could use this data and figure out how much food people are going to buy in every category and buy the right amount so we don't have to have sales to sell off the stuff that is getting stale and such. But I'm sure you can do many, many other things. Anyway, you can optimize your energy usage. And so in operational technology, all the same, you might improve the efficiency. You might be able to predict things and prescribe what's causing problems. Predictive maintenance might help you make your stuff more reliable. And you might find various cost savings as you get to do things more efficiently. That's what you would like to see. Now, the problem is, if you want to have any kind of AI, you have to have a lot of data. And this is why a lot of people are saying, in the world of large language models, companies that own a lot of data, like Twitter and Facebook and the New York Times, are now considering this data as a really valuable asset, and we are going to charge AI models money for using our data to train their models. So you need a bunch of data, and your data has to be protected if it's sensitive, and you have to guard your training process against adversarial attacks that might poison the data and make your model learn to do the wrong thing. And you have to consider how humans are going to be involved, human-machine collaboration. You need human oversight, and you need to make it so humans can understand how to control these models, which is quite a challenge. And of course, you got ethical and legal considerations all over the place. The machine learning models tend to have bias. People tend to over-rely on them as the number one risk I see in practice. They trust the machine learning model when they really shouldn't, because they tend to be unreliable, and so on. There are many considerations of ethical and legal problems that come about from the use of these things. So machine learning, thinking of the sort of curve-fitting sort of thing, is a subset of AI, lets you automatically learn and improve from data without being explicitly programmed, so you can detect faults. And predictive maintenance, you can learn from data what signals from the sensors tell us that this device is about to malfunction and should be serviced or replaced. You can identify patterns in the data, like how many products are being produced per hour, and try to figure out what is the cause of things slowing down, what could make things more efficient. You could analyze data to predict future demand, which is what I was suggesting about Safeway. If you know with great detail what a lot of your customers have been buying and when they've been buying it, then you can probably predict how much you can expect to sell at certain times of the year as holidays go by and such, and carefully arrange your inventory to do a better job. Same thing with your energy consumption and quality control and inspection. All these things are good candidates for machine learning rollouts. So you ought to get better efficiency, better prediction, better decision making, hopefully reduce downtime and maintenance costs. And you might be able to have continuous improvement. You'll continue to collect data from your processes, and your machine learning model might be able to do batch learning where it keeps improving its model and adapting to changing conditions. All right. So one problem is, can you get enough data, and is the data high enough quality? All data has defects. Sometimes it's wrong. Sometimes you're not able to measure what you really want to measure. In particular, if you consider things like political surveys to predict elections and the mood of the country and whether you should do an initiative, whether it would be popular or not, like whether you should have an abortion ban or something, it turns out to be pretty difficult to measure what people really think. These primary seasons, I've heard a lot of news about how Trump keeps underperforming the polls. And this is the problem. When you ask people survey who are they going to vote for, and then when they really vote, they don't do exactly the same thing. So you can't really measure what you really want. You're measuring something only indirectly connected to what you really care about, and you have to somehow try and cope with that. And then I mentioned before, once you have a machine learning model, you don't understand how it works. So if it's doing something wrong, like Google's Gemini, Google has fallen flat on their face over and over here. They brought out Gemini, and they put out Gemini that could generate images last week, and people, if you asked it to give you images of the founders of the Constitution, it would make them all black. And people said, this is ridiculous, so they withdrew it. They're trying to fix it. Now, how would you fix a thing like that? If somehow your model has learned to do things wrong, there isn't like a line of code you could find to make it change that one feature. You might have to just retrain it all over again with different data or something. That's the problem with interpreting your model. Can you understand what it's doing, and can you somehow control what it's doing when you don't really have clear code you can read and change? You don't really have statements. You can't really say this module does this part and this module does that part. So you got to validate and test your models. You have to consider the security and privacy of sensitive data that may be going in there. And that's why you need human expertise and oversight, humans watching over these unreliable, unpredictable models, trying to understand them and make them more reliable, to detect when they're failing and so on. And so large language models have all the same features. If you have human-like interactions, it seems like you can state your question in plain English and get an answer in English, and to some extent that's true, and to some extent it's not true, because the model doesn't actually understand what you're saying the way a human did. It's just doing like a mathematical prediction of what the next word should be. So sometimes it's very unreasonable, very crazy. So you got problems. You've got, but you might help your maintenance troubleshooting. Most people are adding AI to search engines. Google is, Microsoft is. They say the AI-generated response to a search may be helpful. I find this to be true. When I ask technical questions, and mostly what I ask, how do I turn on remote desktop on Windows 11, the AI-generated answer is usually pretty good. Click here, click here. It's usually pretty nice. Sometimes it's completely wrong, but often it does give me the right answer quickly. And so that's documentation and knowledge management. It may help you generate your manuals. It may help you interpret your manuals. Decision support systems may be helpful, so you can analyze things. This is why all the models that come out, including the latest one that just came out, Claude 3, is very proud of the fact that it can now take a lot of input data, like a whole novel size of input data. So you can feed it, here's my question. Not only that, here's a whole set of PDFs of all our company procedures and technical documents that you should consult when answering this. And that's what they do now. So it helps you do this. See an article, there's new optimization for matrix multiplication. Yes, I saw that. Yes, I saw that go by. Yeah, to make them faster. Yes, there's a new, smarter way to do it, which hopefully will help ease the power requirements for AI. Yeah. Anyway, all right, so this is something, decision support systems and virtual assistants. We've all got versions of these available to us now. I was just listening to a podcast yesterday where they're talking about why is Apple's Siri such garbage. I only tried using it a couple times and I just turned it off. Everybody finds it pretty useless. That was their attempt to make a virtual assistant. Other people are making better ones. Siri and Alexa both seem to not be worth much. Most people I know just turn them off after a while. But we should be able to have virtual assistants that are really helpful. And so that would make a good user experience and make things more efficient. And it would be easier to capture and document knowledge if these things worked very well. Right now they're all in early sort of beta testing stages and not working all that well. So then you would have make it easier for people to learn how to use your systems and onboard, because they don't really have to learn how to write computer code. They just can write their request in plain English. And then, of course, maybe they will continuously learn from user interactions and feedback. So you've got the usual issues of privacy and security of the data that might be sensitive. Accuracy and reliability is the one I keep talking about. This is, I think, the most important thing. The AI, the large language models, are not as reliable as people think they are. And as I say, figuring out how to teach it the specific information needed for your task. The current procedure that is being used for that, I have no idea if it's the best one, is to take a model that was trained on the whole internet just to learn English, and then just add hundreds of pages of specific knowledge before your query to be included in your query. You add that after the training. If you think about it, that's how humans do it. You go to kindergarten, you read Jack and Jill books, you learn basic English, and then later in college you learn like medicine. So first you learn the basics of language, then you learn the specialized technology. That's how we're doing it right now with LLMs. I don't know if that's best. An alternative procedure might be to just start with a naked LLM and teach it specifically on just the technical stuff. Anyway, you got user training and ethics and bias considerations, as we've talked about before. So let's take a look at a Kahoot about this. And there they are. Favorites. OT Chapter 9. Yeah, but that comment there, that is a big issue. That's why, the current LLMs are not that good, and people keep casually saying they're going to get better. But then people say we're already hitting the limit of the amount of hardware we can afford, the power consumption, and so on. So news articles like the one mentioned there by the student, using new techniques to make them more efficient. There's a lot of need for that. It's unclear how good these things are going to get before we hit the limit of our capacity to improve them. Everybody's betting very heavily right now that they will get a lot better than what they are. If they stop at this level and don't improve, then I think the whole AI boom will fizzle out. But nobody expects that. Everybody expects them to get a bunch better, to where we're just using them all the time everywhere. All right. All right, so what technology would analyze reports and archives? Yeah, those are LLMs, which are technically AIs and MLs also, but that's what they're good for. Understanding language is what large language models are good for. Or at least simulating an understanding of language. All right, which item ensures that people are overseeing automated processes? Of course, this is human-machine collaboration, and this is something like we brought it up in the news article earlier. When somebody makes a drone with facial recognition and a bomb on it, and they send it off to kill somebody, that's the problem. You don't have a human in the loop. That's when you have these science fiction nightmare scenarios where these killer robots are wandering around and there's no human controlling them. Nobody wants that now. Even the military doesn't want that. They supposedly have a human in the loop all the time, because the machines are just not reliable enough to trust them to make really important decisions like that yet. All right, which one would predict demand and optimize inventory levels? Yeah, that's your supply chain optimization. This can bite you. You know, when COVID hit, our supply chains were so optimized that nobody had extra stuff waiting in warehouses. They had just-in-time systems. So when COVID hit and the ships stopped coming, they were all hosed. They didn't have like a warehouse full of the parts so they could get by for a while and find some alternative way to ship it. So optimization is an interesting question. Do you optimize for profit today, or do you optimize for resilience in the future? Those are different possible goals. Anyway. All right. All right.